In this video, I want to offer you a brief introduction to the characteristics of a quadratic function in standard form. This video is great if you learned about quadratic functions in class, but maybe need a little refresher, or if you're just looking at this material for the very first time. In either case, for a quadratic function to be written in standard form, it must be written in the form ax squared plus bx plus c, where a, b, and c are going to be real numbers. But we have this limitation that a cannot be 0. Of course, if we allow a to be 0, then the function would no longer be quadratic because it would zero out this quadratic term, and all we would be left with is bx plus c, which would be a linear function and not a quadratic function. Okay, so a, b, and c are real numbers, and a can't be 0. And you'll see in an example right up here, we have a function f of x equals 2x squared minus 12x plus 15. Okay, so we see it's going to be quadratic, and we see it's in standard form. So our leading coefficient, okay, so a coefficient here, and the leading coefficient means, the number out front of the highest degree term, and that's our a value. So in our case, our a is 2, and we call that the leading coefficient. Our b value is going to be the coefficient of this middle term, which is our linear term. So it's going to be the coefficient, so negative 12. And our constant is just going to be this number out here that's just coming along for the ride. He does not have an x or any other variable along with him. Okay, so what we're going to do is we're going to take a look at this quadratic function. We're going to walk through a series of characteristics. We're going to talk about the vertex, the axis of symmetry, whether the graph of the quadratic function, which is a parabola, whether it opens upward or downward, the domain and range, and stuff like that. So let's go ahead and get started. So we know that when we graph a quadratic function, it's going to be in the shape of a U. We actually call this a parabola, and it has special characteristics of its own. Okay, so we know it opens up or it's going to open down. Of course, you can have parabolas that open sideways or kind of any which way you like. But for now, probably you're looking at this in Algebra 2 or maybe the end of Algebra 1. We are going to be looking only at parabolas that open upward or open downward. Okay, and so of course we have this point called the vertex, which is going to be here on an upward facing parabola or here on a downward facing parabola. And so this vertex is going to be an ordered pair, so it'll have an x coordinate and a y coordinate. And so the x coordinate will be given by this little formula. It's not too bad. It's the opposite of b over 2a. Okie dokie. Well, we have our a and our b values right here. We got those from our function up here. So let's just go ahead and plug those values in. So the x coordinate of our vertex is the opposite of b. So it's the opposite of negative 12, that was our b value, over twice our a value, and our a value is 2. So let's go ahead and simplify this. So the opposite of negative 12 will be positive 12. 2 times 2 is 4. I'm going to reduce that a bit, and I'm going to get 3. So I can say the x coordinate of my vertex is going to be positive 3. All right, well, how about my y coordinate of my vertex? Well, remember, functions kind of are like input-output machines. My x value is something I can plug in, and the y value is something I get out. So I'm going to go ahead and plug this 3 into my function, and I'm going to evaluate my function at 3, and that will be the y value of my vertex. So let's go ahead and do that. So we have 2x squared. So 2 times my x value, which is 3, and I'm going to square that, minus 12 times this x value, which is 3, and then plus 15. Okay, let's go ahead and shuffle this up so we have some room to work. So order of operations here looks like we have a nice numeric expression. And so let's do our exponents first, because exponents are higher on the order of operations food chain than, say, multiplication. So 3 squared is 9. 3 times 3, so 2 times 9 minus 12 times 3 plus 15. 2 times 9 is 18. 12 times 3 is 36, so we'll subtract those, plus 15. So it looks like we have negative 18 plus 15, which will be a nice negative 3. So this negative 3 will be our y value. So our vertex then is this x value that we found previously, so positive 3. And our y value here is negative 3. So here is our vertex. Okay? Another thing that we talk about is the axis of symmetry. I'll just write that down real quick. And we have a nice little formula for that as well. It's going to be x equals the opposite of b over 2a. Interesting. We've seen this before, right? X equals the opposite of b over 2a. Well, in this case, it was the x-coordinate of our vertex. And in this case, this is a vertical line. X equals some value here. And it's going to be the equation of a vertical line. And so, let's talk about what that looks like. When we have our parabolas, we're going to put this vertical line straight through the vertex. And you'll see that it kind of breaks this parabola up into two legs, and they're going to be mirror images or mirror opposites of each other across this line of symmetry here. And our line of symmetry is always going to be a vertical line in our cases. And so even the upward and the downward opening parabola, same thing. We have this axis of symmetry, and across that axis of symmetry, these two legs are symmetric to one another. Okay, so let's go ahead then. So the axis of symmetry is x equals, since it's a vertical line, and this x value here, well, we already found that out to be 3. So the axis of symmetry is a vertical line whose equation is x equals 3. Okay, so another thing, and before I get too carried away, let's go ahead and rewrite this function so I have it down here again so I don't have to keep, going back up to the top of the page. Okay, so here we were. So let's talk about whether, in our case, the parabola is going to open upward or it's going to open downward. Okay, well, how do I know? Well, it opens up if our a value or our leading coefficient is greater than 0, or positive. It opens downward if our a value or the leading coefficient is less than 0, or of course negative. Okay, so we can see in our case our leading coefficient is positive, so this one is going to open upward. So we'll have an upward opening parabola for this quadratic function. Okay, another thing that we might consider is this vertex a maximum value or a minimum value of this graph? So if it's an upward facing, the vertex is down here, which means it's a minimum. If it's a downward facing, our vertex is here, which means it's a maximum. And of course, in our case, since we are opening upward, this vertex will be a minimum value of the function. Okay? Let's see. We can also talk about domain and range. So I'll write those down and we'll do these. So the domain and the range. So remember in words here, domain is all acceptable x values. So what can I plug into my function and not cause division by 0 or the square root of some negative value or something like that. So in our case with quadratic functions, we're not going to have any limitations on the domain. I can plug anything in for x because all we're doing is squaring and multiplying and that kind of thing. So I have no limitations on the domain. So the domain will be, I'll write this in interval notation, negative infinity to positive infinity. Okay? You could also say, all real numbers. Our range, however, concerns itself with the y values. In words, what are all the possible y values that I could get out, or my output? And we know that the parabola looks like this. So we have this minimum value for our y, and then we have everything going up from there. So our range will be this minimum y value, which, let's see, we can get from our vertex. We know it's negative 3. So it's going to be negative 3 up to positive infinity. Infinities always get parentheses. And we'll put a bracket here on this negative 3 because it is included in our range. So this vertex here is included, so we'll put a bracket right there. Okay, so we have the domain and range as well. And maybe let's look at one more thing before we take a look at the graph of this function. We'll look at where, let's see, where our function is increasing and where our function is decreasing. Okay, and so we know once again that this parabola is going to open upward, which means the two legs are going to be symmetric about this axis of symmetry. So in our case, the left leg is coming down, 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 so it's decreasing until we get to the vertex. And then after it hits this vertex, it turns around and it's just increasing, increasing, increasing. So the first thing it's doing is decreasing on the left leg. So it's going to be from negative infinity up to, well, it's the x value of our vertex, so up to 3. And then it picks up from that 3 and starts to increase, and it does so forever after that. So we know it's increasing from the vertex to the right, so from 3 to positive infinity. And we know it's decreasing from negative infinity, so all the way to the left, and it stops decreasing at that vertex. So putting this together, it's decreasing here, it stops decreasing at the vertex, and then starts increasing after the vertex. Okay, so that's just kind of a quick overview of a parabola in standard form, how we can find its vertex, the axis of symmetry. We can kind of talk about the vertex as a minimum or a maximum value. Also, if the parabola, or the graph of our quadratic function, opens upward or downward. And for some extra stuff, we can talk about the domain and range, and where the values, or where the function is increasing or decreasing. So we can put all of this stuff together, and let's go ahead and end the video by showing you the graph of this quadratic function in standard form.